Hello students, and welcome to the CompTIA Security+701 Exam Course brought to you by Third Level Technology. I am your instructor, Jim Herbie. In this episode, we're going to continue in the exam objectives by discussing the first half of Section 1.2. Our topic is Security Fundamentals. Let's begin.
Our first topic we're going to discuss is the CIA security triad. The CIA stands for confidentiality, integrity, and availability. The C, confidentiality, is where we are protecting our data and information from unauthorized access. The I, or integrity, are ways that we can protect our data from being modified in an unauthorized way. And A stands for availability. This is ensuring that our data and our systems are accessible when needed by our users. C is confidentiality. This is where we want to make sure that our data and information is only accessible to those that have the proper authorization and permission to access and view it. With confidentiality, we can use techniques such as encryption and access control lists to create ways to authenticate only authorized users to data and system resources. The I stands for integrity. This is making sure that our data remains accurate throughout the transmission process. Integrity is making sure that our data is not modified or tampered with in any way as it is going from its source to its destination. The A stands for availability. This is making sure that our data and network resources are available and accessible to our authorized users. The steps that we take to prevent and mitigate any disruptions to our normal operations. Some ways that we can enforce availability would include having data backups, redundancy. Redundancy is when you have multiple of a hardware device so that if one goes down, the network resource can still remain available, as well as disaster recovery. This is the steps and the plans that we have in place to restore our data and systems after some type of disruption. Our next security framework is non-repudiation. Non-repudiation is the security technique we use so that a user or an individual cannot deny the authenticity of their signatures or messages. Non-repudiation is especially important when dealing with any type of legal or regulatory concern. This is where the proof of an action or proof of an agreement is very important. There are three common ways that we can implement non-repudiation. The first is through digital signatures. A digital signature is a way that we can identify a person through a cryptographic signature that is assigned to a person's document or message, like an email. Another type of non-repudiation technique is time stamping. Time stamping is when we get an exact date and time of day when a document was created or a message was sent. It helps us to prevent an individual from denying the occurrence or existence of a certain message or document. And a third way that we can implement non-repudiation is through public key infrastructure, PKI, feature called certificate authorities. Certificate authorities are organizations that create and validate digital certificates. These are validations of websites that allow our users to verify that the website they are visiting is unique to the owner and that it has proper security encryption techniques so that our data that is being accessed cannot be stolen by an attacker or a third party. The next security framework we're going to discuss is AAA security. This stands for authentication, authorization, and accounting. Authentication is where we are verifying the identity of our users or network devices. We're making sure that our users and our devices are who they claim to be. Authentication uses passwords as well as biometrics as the most common ways to authenticate our users. Biometrics are when we identify a user based off of some physical characteristic. Fingerprint scan, an eye scan, a facial recognition pattern, or a voice print. All of these are examples of authentication. Authentication also can use a technology called tokens. This is when we use an encrypted identifier that exists either on a smart card or generated by an authenticator app to also verify an individual's identity. The second A is authorization. Authorization is the amount of network access that is granted to authenticated users and devices. Authorization will determine what types of files, resources, or services can a user or a device access once their authentication has been approved. We can configure authorization policies through permission levels, user roles, and access control lists. And the third A is accounting. Accounting is how we can create records that will track the activities of our users and devices on the network. This is where we can create records and archives for things such as user logins, file accesses, and network traffic. So remember, authentication is verifying users' identity. Authorization is granting network access to authenticated users. And accounting will be records of all of the activities for our network users and devices. The next security framework we're going to discuss is gap analysis. And gap analysis is when we create security policies to help us identify any weaknesses in our business security systems. The first step is establishing criteria. In order to identify weaknesses, we have to have a baseline that serves as the accepted standards. A common way that we can establish a criteria is HIPAA, HIPAA. HIPAA is a set of rules and regulations that govern the way that we handle our users' healthcare and health data. The second step in gap analysis is assessment. Once we have established the criteria that we're going to use, then we need to conduct a full testing or assessment of our current security policies and practices. The third step is identifying the gaps. This is where we will look for any types of missing security controls, non-compliance, or outdated technologies that exist within our security system. Next, we would do prioritization. This is when we will take a look at all of the different security gaps that we have, and we will rank them, poses the higher security risk, and should require our immediate attention. And lastly, in gap analysis, we will develop a remediation plan. This is where we will develop a plan that will outline the different steps that we will need to address each gap, create new security controls, training programs, and identify any new hardware or software technologies that would help us to improve our overall security posture. Next, we're going to discuss zero trust. And zero trust is a security concept that says that we should always verify the identity of our users and that our data is being sent in an encrypted form across the network. With zero trust, we have two parts. We have the control plane and the data plane. The control plane is where we have a centralized management layer that will enforce all of our access policies. We use the control plane for our authentication. We can create biometric authentication, smart cards, and multi-factor authentication policies within the control plane. We can also use the control plane for automation. This is where we can create scripts or some other type of security control that can be managed by program code. all of our security policies related to our data carried out without the need for manual intervention by our administrators. The control plane also allows us to control identity and access management, IAM. This is when we can use the control plane to authenticate all of our users and create access permissions based on their job role and responsibility in our business. Let's contrast that with the zero trust data plane. The data plane is focused on protecting our data as it is moving across the network. With the data plane, a common component is encryption. This is where we will use encryption algorithms to change our data from plain text to an encoded version called ciphertext. And this makes our data unreadable unless you have the appropriate public and private keys to encrypt and decrypt the data. We also use the data plane to create data classifications, give different permission levels to certain types of data to help our users access the things that are important to their job duties and functions. Another component of the data plane is masking. Data masking is when we will take sensitive data within a document or database and obscure it from view. We can use features like redaction and encoding to make certain sensitive data parts of a document or a database be unreadable to a third party.
That will conclude our discussion of the first half of Section 1.2, Security Fundamentals. In our next episode, we will discuss the second half of Section 1.2, and our topic will be Physical Security. We thank you again for following along in the episodes and the course, and wish you best of luck in your studies. Enjoy the rest of your day.